Last day on verifying trig identities, and this time we're going to be focusing on finding a common denominator when we have to simplify our trig expressions. So we've got example 1. On the left-hand side, we are adding fractions. Some students find it helpful to put that second expression over 1 so that they can see the two fractions. And in order to add fractions, we need a common denominator. So in this case, our common denominator is tangent, which our first fraction already has. So we multiply our second fraction by tangent over tangent. Remember when you're multiplying an expression that you need to multiply by a form of 1. If you're not multiplying by 1, you're changing the value of the expression. Of course, tangent over tangent is equal to 1, so we're not changing the value of this expression, we're just changing what it looks like. Multiplying, we have our 1 plus tangent for our first fraction, plus our second fraction, we get tangent squared over tangent. Once we have those common denominators, then we can add our fractions. So in the numerator, we get that 1 plus tangent squared. I hope you recognize that that looks like a Pythagorean identity. Off to the right here, we're going to manipulate that Pythagorean identity. It's tangent squared equals secant squared minus 1. So if we add 1 to both sides, we get tangent squared plus 1 equals secant squared. Back to our equation, I'm going to replace that 1 plus tangent squared with secant squared. So we have secant squared over tangent, which equals the right-hand side of our trig identity. Our next example doesn't look like we would need a common denominator. However, in order to turn addition into multiplication, what I'm going to do is use the quotient rule for tangent and cotangent and rewrite them in terms of sine and cosine. So tangent is sine over cosine, and cotangent is cosine over sine. Now that we have them as fractions, we need a common denominator in order to add our fractions together. So I'm going to multiply my first fraction by sine over sine. And I'll multiply my second fraction by cosine over cosine. Simplifying my first fraction, I've got sine squared over sine times cosine. Second fraction, we've got cosine squared over sine times cosine. Adding our fractions together, we'll get sine squared plus cosine squared in the numerator, all over sine x cosine x. Hopefully by now that you are recognizing what this numerator is equal to, one of our Pythagorean identities, which I said we would be using quite a bit. Sine squared plus cosine squared is 1. So we have 1 over sine x cosine x. So we can split this fraction up as 1 over sine x times 1 over cosine x. Of course, the reciprocal of sine is cosecant, and the reciprocal of cosine is secant, which equals the right-hand side of the expression we started with. Taking a look at our next example, if we look at the right-hand side, this one has a fraction, so that's the side that's more complex, so we want to simplify that. But when you look at it, you can't butterfly unless the denominator is a single term. So initially you might feel stuck. How do I simplify this expression when there's nothing I can do with it? Another option is to multiply by the conjugate. Remember, when we rationalize radical expressions, we multiply by the conjugate. We're adding something in there that wasn't there to begin with. But as long as you're multiplying by a form of 1, that's okay. So we're going to multiply by 1 plus sine y over 1 plus sine y. In the numerator, I'm going to go ahead and distribute that cosine, so we get cosine of y plus cosine sine. In the denominator, remember with conjugates, we can skip the OI of FOIL and just multiply the first and the last. So we get 1 times 1 is 1, minus sine times sine is sine squared. Again, hopefully you recognize that Pythagorean identity in the denominator. 1 minus sine squared is cosine squared. Now that we have a single term in the denominator, we can go ahead and butterfly this. So I'm going to split it up as cosine over cosine squared plus cosine sine over cosine squared. Of course, in each of these, we have a cosine that cancels. So our first fraction, we have 1 over cosine. In our second fraction, we again have a cosine that cancels. So we have sine over cosine. The reciprocal of cosine is secant. And sine over cosine is tangent. So now we have the left-hand side of the expression matching the right-hand side. Our final example, notice the note on the right-hand side. This time both sides of the equal sign are complex, so we are going to spend some time simplifying each side of our equation in order to try and get them to equal out. I'm going to start with the left-hand side. Again, we've got that denominator where we can't really do anything with it. That cosecant isn't squared, so it's not a Pythagorean identity. So I'm going to go ahead and multiply by the conjugate 1 minus cosecant over 1 minus cosecant. I'm going to stick to one side until I get it fairly simplified and then see if I can't get the other side to match it. In the numerator, I'm going to leave this one factored until we see what happens. If I need to distribute later, I can always do that. So we've got the 1 minus cosecant x. All over in the denominator with those conjugates, we can multiply the 1 by 1 and the cosecant by itself. Now in the denominator, we have a Pythagorean identity, but it's one we haven't worked with a whole lot. So I'm going to write this down off to the left. It's cotangent squared equals cosecant squared minus 1. Now what I want you to notice is that it's in the opposite order from what we have in our equation, the 1 minus cosecant squared. So if I multiplied this by negative 1, golden rule, I have to multiply both sides by negative 1. Then on the right-hand side of this equation, distributing that negative 1, and I'm going to switch the order. The negative 1 times negative 1 is 1, and the cosecant times negative 1 is minus cosecant squared. And of course, on the right-hand side, multiplying by negative 1, we get negative cotangent squared. So what I can do is replace in my equation the denominator with negative cotangent squared. Because I'm going to need a lot of room to work on this one, I'm going to erase the Pythagorean identity we just looked at. So if you need another minute to write it down, make sure you hit pause. So we've got our cotangent squared times the quantity 1 minus cosecant in the numerator. And in the denominator, we're replacing that with negative cotangent squared. So now we can cancel our cotangent squared, and I'm going to bring that negative up in the numerator, so it becomes cosecant, becomes positive, and the 1 becomes negative, so I'm going to flip it around. All right, so I have my left-hand side fairly simplified, so now I'm going to go ahead and take a look at simplifying that right-hand side as well. With this one, I can split this up with the butterfly method because we've got one term in the denominator. So I have 1 over sine x minus sine over sine, which is 1. 1 over sine x, the reciprocal of sine is cosecant. So we have cosecant x minus 1, which does equal how we simplified our left-hand side.